We'll be celebrating Pi Day. Um, oh boy, I might need to recalibrate this. Uh, Pi Day, let me pause this because I'm about to blabber on here for a second. Yeah, so I was about to write the date. That was what inspired me to talk about Pi Day. So Pi Day will be uh, not during school. So what we're doing is what we've been doing. We're solving log equations, but they're going to have variable bases. So when you take your quiz on log equations, it will not be broken up into what we've been doing plus what we're going to do. It'll just be all together. So there'll be one section of log equations with constant bases like E, 10, 7, 4, like what we've been working with. And then there'll be a section of log equations like what you're going to see today. And if your basic algebra is pretty good, you're not going to struggle with anything that we do today. It's a little more like there's a little more upfront work, but then if you know how to solve quadratic equations, you're going to be just fine. No issues at all. So let's start with this little fella. So we're going to have a log with a base of x plus 3. And the argument's going to be 2x plus 14, 2x squared, sorry, plus 14. And we're going to set that equal to 2. Boy, that was a really long, rough start to the class. Sorry. I'll try to go quickly. Um, you're not going to see any log droppers today, like none of that stuff. Today's going to be on like the rinse and repeat cycle. So what we're going to keep seeing are log equations like this, where the first thing we have to do, no condensing either, by the way. So the first thing we're going to have to do right away is just convert this over to exponential. So remember, we don't solve log equations as much as we change them into exponential equations and then solve that, right? So we're going to just cycle this out. So we're going to say x plus 3 to the power of 2 equals this. The same thing we've done probably 100 times by now. So I am not going to skip this, though. I'm not going to write down what the answer to that purple arrow is. I'm just going to write down what it looks like. So it's x plus 3 raised to the power of 2 equals 2x squared plus 14. There's zero chance you're lost already because, again, this is just the water cycle looking thing we've been doing for probably, 2 weeks now. So we do have to, though, cross this bridge. And I don't want to yell at anybody today. So I am very sort of apprehensively going to ask, what is the answer to this? And if you say x squared plus 9, you will be sent to Mr. Townsend's office. Just FYI. A little heads up. Anybody want to get in there and take a shot? What's the matter? You scared? Come on, chicken. Let's go chicken pants.
We can. I would have been sent to the opposite.
That's why I said that. So let's remember, and I'm going to write this down for you just one time, and then we're not going to go over this step by step every time. And I'm going to erase. So the good thing about recording is I can erase what I do because it'll live forever in recording with pause and rewind. So here's what x plus 3 squared looks like. Just a friendly reminder. And this is not x squared plus 9 because there are 4 steps to multiply these. And we'll usually just do this in our head. We'll do like square, square, multiply, double. It's real quick and easy. So if we just do x times x, yes, we get x squared. If we do x times 3, we get 3x. Just remember this. And then if we do 3 times x, we get another 3x. And then if we do 3 times 3, yeah, we get 9. So when people say ridiculous things like x squared plus 9, like I get it. I don't fail to see your logic there, but you're completely just thumbing your nose at the purple and the green, right? Remember that it takes 4 multiplications to multiply 2 binomials, not just 2. It's not just what you see. So this becomes x squared plus 6x in the middle plus 9. So the x squared plus 9, yeah, it's part of the deal, but it's not the deal, right? The way we do this going forward without having to show all that stupid work is we just do square, square, multiply double. So um, you take the red thing, square it. What do you get? That. And then you take the purple thing and you square it. What do you get? That. But then the thing you have to keep doing quickly in your head is the multiply double step so that we don't have to go through this every time. So you take the purple thing and the red thing and you multiply them together. What do you get? 3x. Double that. What do you get? There's where the middle comes from. So we don't have to keep going through the steps. Okay. So anyhow, the left side becomes x squared plus 6x plus 9, and the right side is still 2x squared plus 14. And just like you're used to, this is just a run-of-the-mill kind of algebra 1 quadratic equation. So which side do we want to move all of our stuff to, right or left? Definitely to the right, because remember, we don't want to lose the positivity x squared. So we're going to subtract the x squared across and get 1x squared. Who else is moving? We got to do minus 6x. He doesn't have anyone to go with, so he'll just kind of situate himself right next to the x squared. And then we also have to move the 9, right? By subtracting him, and what's 14 minus 9? Good, that went well. 5. Yep, there. So this is what the quadratic looks like when it's all set up and ready to go. And of course, we're going to factor, right? I didn't give you any today that are not factorable, either in the notes or in the assignment. Everything is factorable, okay? So no sweat here. And if they're not factorable, then I boofed it. I was trying to write these last night and I think I quality checked them, but it wouldn't be the first time you've seen me do something bad. So we're going to factor this down into x minus, and what numbers are we looking for? 1 and 5. Good. So what are the potential solutions to this equation? X equals 1, or maybe x equals 5, or maybe both, or maybe neither. We're not sure yet. So we're going to go back to the very beginning of the problem, and we're going to plug those numbers into the arguments and the bases. Okay, you got to go everywhere with these now. So that kind of adds an extra little twist. So our first candidate is x equals 1. So if we take 1, so follow my kind of yellow arrows up here on the board. If we put 1 right there, we don't have any problems. What is the base not allowed to be? Huh? It can't be negative. What else can't it be? It can't be 1. What else can't it be? 0, right? And so the base is pretty picky. Like the base says, there's a lot of stuff I'm not allowed to be, right? So if you were to put 1 in there and that base would become something like a 0, then you'd right away say that you're no good. Okay, so he passes the first test because that's 1 plus 3 is good, 4. And then if you put 1 up here where the other yellow arrow is pointing, we're good because 1 squared is 1 times 2 is 2, 2 plus 14 is, we're fine. So 1 can have a pass. All right, so we're going to box them. Remember, we box them if they work, we cross them if they fail. Never leave an answer naked. Not with this type of stuff, okay? They either get box commitment or cross commitment. 5, are we going to have any problems with 5? Same thing. If you go and look at those yellow arrows, he's not going to cause any trouble anywhere you put him. So again, we're not checking the mathematical accuracy of it. We're just checking to see if any laws get broken. So 5 also is fine. And so he can have a box. And that is how you generally just solve a log equation with a variable base. All right, let's cook through some more. Good for the next one? Log base 2x of 3x squared plus 3x minus 2 equals 2. You're going to see a lot of this equals 2. By a lot, I mean like every problem, because what we're trying to do here is get you to, because we're in Algebra 2 class, not like Algebra 3. So we're not going to be cubing variable bases because then we create like cubics and we'd have to bust out some gnarly big guns there. So you're going to see that on, I think, every problem, quite frankly. Okay. So step 1 is to take this to the power of this. What does that equal? Well, yeah, depending on what you're saying, it is the quantity of 2x squared. But maybe more what I meant was, what does that actually equal? It equals 4x squared. So let's just go ahead and put 4x squared. Okay, remember when you square something, you square all of it. And then we're going to set that equal to the argument of the log, which is 3x squared plus 3x minus 2. And again, it's just quadratics 101. Which side are we going to go with, left or right? Yeah, we're going full left here. And again, it's never about where do I have to move less terms. It's about I shall keep my x squared positive, right? So we're going to pull the 3x squared over and get 1x squared. We're going to pull the regular 3x over and get minus 3x. And then we're going to pull the minus 2 over and get plus 2. And there he is, ready to go. The factoring should not at any point feel super taxing, okay? So this is, again, I think pretty low level, kind of rookie level factoring. What are my factors? No.
Oh.
So x minus 1 and x minus 2. Good. So what are the solution candidates? X equals 1 and x equals 2. So let's go back and do a little quality check on those. So we're going to put in 1 first, and then we're going to put in 2. And again, you want to go back to the very beginning and just make sure that no laws get broken. If we put 1 right there, no problems. If we put 1 up here where these other yellow arrows are, clearly no problems. You don't even have to know what this actually equals. You just have to know that 3 times 1 plus 3 times 1 minus 2, it's going to be positive, right? So he passes all the tests that we had for him, so 1 can stay. And you would agree that 2 is going to be the exact same ride, right? If you go up and put 2 in place of all those, you're going to get a positive base and a positive argument, so we are good to go. So again, 2 solutions, both of them work. Please don't get the impression from these first 2 examples that the answers just always work. So I went out of my way. Even if it doesn't show up in this next problem, you'll start to see some problems where the answers, one of them or both of them, maybe don't work. Just FYI. Okay. Good for the next one? All right, let's do log base negative 2x minus 3 of 3x squared plus 4x minus 6 equals, you guessed it, 2. So I'm not going to go super fast on this one because I do think it's time well spent if we can sit and practice our square, square, multiply, double skills. And I've done no math, right? None. I've done nothing but comply with the expectation that I converted over to exponential, right? But at this point now you have to do some math. And so let's talk about the square, square, multiply, double algorithm. So if I take red and purple, and I would be deliberate if I were you, pay close attention to signs, right? You have figured out this far into your career that little oops, forgot the negatives aren't very cute, right? So let's take the red thing, all of the red thing, and square it. What do we get? Come on, don't be a turkey. Square the red box. Thank you. Thanks for taking off your chicken pants. 4x squared. Square the purple thing. What do you get? Plus 9. Good. And I'm going to leave a space and put plus 9 at the back because in the middle I have to do the multiply double step, right? The 2 middle-y term kind of things that I don't want you to see them. I just want you to talk about them. If you take the red thing times the purple thing, what do you get? Positive 6x. Double that. There you go. So every time you square a binomial, just follow that algorithm. Square, square, multiply, double. Every time. It works every time. Quick, easy. And hey, for the 3rd straight time, we're going to have just a basic quadratic equation. And our training kicks in. Which side are we going to? Left it is. So again, we're pulling 3x across to get 1 of those. We're subtracting 4x across to get 8 of those. And we're adding 6 across to get 15. And as advertised, that's some pretty light work factoring right there. So this is going to factor down like this, this. Of course, they're both pluses. What numbers are we looking at? For sure, 5 and 3. Yeah. So who are my candidates? -5 and -3. So we have maybe x equals -5. He's in the running. And maybe x equals -3. So let's go back up to the very beginning and do some basic math, just one at a time. Let's just start with -5 with a question mark. If you put -5 right there, math that out. What's -2 times -5? 10 minus 3 is 7, so I can put a little green check mark like you passed. Okay? Put -5 right there, and you get 25 for the yellow jelly bean. 3 times 25 is 75. And at this point, we just don't have enough subtraction over here to dwindle that down below 0. So we can put a green check mark here as well. If you want to calculate it all the way out, you're welcome to. I think it's obvious that it's going to be positive. So that's enough information for me. So -5 can have a box. Okay, let's go check -3. Same thing. Back up here, we're testing -3 now with a question mark, like, do you work? If you put -3 in the first one, what's -2 times -3? 6 minus 3. He passes. Okay. And then if we put -3, I don't know what that was, by the way. If we put -3 in the yellow jelly bean, what's -3 squared? 3 times 9 is 27. And then 4 times -3. Again, I can see that we're just not going to have enough minusness to take away a full 27. So he passes the second test as well. So to this point, we've seen 6 solutions and all of them have worked. Got it? You still with me? Fergie, are you still with me? Wait, you okay? Hey, you want to guess what it equals? There you go. Oh boy. So step 1 is this to the this. Can you do it in your head? What's x minus 4 squared? Here, I'll show it. I'll just write it over here, just so you get eyes on it. Square, square, multiply double. What goes at the back? Plus 16. And in the middle, say again, minus 8x. Nice job. That's how you do it. And yet again, just a basic quadratic. Let's stockpile everything over on the east side, because again, we're always going to go to wherever x squared won't go negative. So we got positive x squared over here. How many x's are we going to have? 13, because we added 8x to both sides. And then what's our constant going to be? Minus 30. When I wrote this problem, I thought I had botched it because what's the first thing people generally would gravitate to here is either going to be 3 times 10 or 5 times 6. And 3 times 10 looks so tasty because 3 plus 10 makes 13. It just doesn't work because of the negative on the 30. So good, I heard you say it. Good job. So we're going to break this down using 1 plus and 1 minus. And Parker did say it. Some of you probably also have figured it out. What numbers multiply to make 30 that we like? 15 and 2. Good job, guys. So we have a positive 15 and a negative 2. So my answer candidates are x equals -15 and maybe x equals positive 2. So remember, they're out there naked right now because we're not committed either way. We're like, we got to vet you, check you out, and see what you're going to do. So let's head back up and check negative 15. If you put negative 15 right there, what do you get? Negative 19. Log arguments cannot be negative, so this answer is gone. Okay, let's go check 2. Head back up to the beginning. Pop a 2 where that arrow's at. What's 2 minus 4? Negative 2. So once again, we realize neither of you guys do me any favors. So this is actually an equation that has no solution. So now you've seen equations that have 2 solutions. You've seen an equation that has 1 solution. Let's do one more and see where this takes us. This is the last example, I think. That's good news, right? I made some pretty good time for me, I think. Step 1. Yeah, hit this to the power of this, right? And I want you to get quicker at this. Yeah, and I don't want you to get it right, but I do want you eventually to not stumble over it. I want it to be like minus 24x. Well played, sir. And then at the back, solid work, Parker. Solid. Okay. So again, the 9x squared and the plus 16 come from very obvious places. Like, duh, we're just squaring things. The 24 in the middle is tough because you've got to see 2 things being multiplied together and then double what you get. So we're going to set this equal to this. And our training kicks in. And which way are we going, east or west? West, right? We're heading towards California with these ones. So we're going to subtract that 7x squared because we want to make sure we get a positive amount of x squared. So we're going to get 2. How many x's? ¿Cuántos x? ¿Cuántos x? How many x? Did you say 5? Negative 5 works for me. Good. And what's our constant? Yeah, it's a nice positive 3. So and there we have it. So maybe a slight step up in factoring difficulty, because there's a 2. But we're not rookies. We're not scared. Tell me about my signs. No, minus and a minus. They both have to be minuses because they multiply to make this beautiful plus sign at the back. They could not be one of each. It's not possible. So, and you don't have a lot to check here with the 3. It's either a 1 and a 3 or a 3 and a 1. And it wouldn't make sense to put the 3 here because it would get buffed with the 2. So it only makes sense that the 3 would go here to get weakened and then put the 1 here, right? So there's our minus 3 and our minus 2 to make our minus 5. So, hoo-ha, we got it. So, what are my candidates for solutionosity? It's 3 over 2. Mhm. And then this one is obviously 1, right? So we do what we do. We're not out of the woods yet. We got to go check and see if anybody works, if anybody fails. And you just check them one at a time. So let's go check 3 halves. And, you know, if you like, it's a dumb way to say it. You should think of 3 halves as 1.5 in this case. And the reason is because being in high school, you all know what the answer to this yellow box is. What is 3 times $1.50? 4.5? I agree. And 4.5 is huge because if you take away 4, you get a positive value, don't you? So 1.5 passes the first test, right? Remember, the base just can't be 0, it can't be 1, and it can't be negative, but it could be a half. That's fine. And then head over here and let's see what happens if we go where these other yellow arrows are. So um, this one's gonna, I feel like this one's gonna be kind of tight, like kind of close. So I'd probably use a calculator on something like this because it's close enough where I'm not comfortable just eyeballing it. So yellow jelly bean goes first. What is 1.5 squared? So I can't hear you, bud. No, I literally can't hear you. It is. Yeah, I just 2.25. So I'm going to take 7 times 2.25 minus 19 times 1.5 plus 13. It just feels like this is going to wind up being, I don't know, kind of close to 0, maybe. So let's do that. 7 times 2.25 minus 19 times 1.5 plus 13. Oh, that was really close. My spidey sense was accurate. The answer came out to 0.25. Are we good? We are. And again, we just have to be really cognizant of the rules. What is this guy not allowed to be? What's this guy not allowed to be? The base isn't allowed to be certain things. The argument's not allowed to be certain things, but they both pass their respective tests. So 1.5 can have a box, or three halves can have a box. Let's go test 1, see if he works. This will be an easier test. We're not going to need calculators for this, like a bunch of rookies, right? What is right here? Red arrow, boom, right there. What's 3 times 1? What's 3 minus 4? We're out. So -1 gets a cross out, or 1 gets a cross out. So that's the gist. It took half an hour, which not even at 25 minutes maybe, but that's how you do it. I'm going to hand out your next assignment. I think tomorrow will probably be a work day just for your planning and preparation, but let's see right now in the last 5 minutes if we can maybe knock out a problem. What do you say? Can you do it? All right. All right, just to make sure that we're all off and running, we're going to start here with our base of our log. I'm going to zoom in on this just a little bit more. I think someone just got murdered in the hall. I'm so sorry you guys had to hear that. So we're going to take the x plus 8 and we're going to square it. And can you just tell me what the answer to that is? Wonderful. Okay, so that first step, you don't want to shoot yourself in the foot like right out of the gate. You don't want to forget an X or something like that. So make sure that everything is good. And now we're going to relocate which side. In this case, it's going to be moved to the right because the 3x squared can receive a subtraction of x squared and remain positive. How many x's will we have sitting next to him? -8, good. And then our constant is going to be minus 64. And we're going to set that equal to 0.
That's a good time to have that paper.
It's been a hot minute because I know that you're thinking now, oh my gosh, 64 has a lot of factors, but you can divide this whole equation by 2. I realize that maybe not everyone is fully listening right now, but dividing everything by 2 is massive because it can knock your equation down to something a little less scary. You can knock it all the way down to 0 equals 1x squared minus 4x and minus 32. And that's a lot more delicious than its predecessor. So at this point, you probably don't need your factor sheet to help you with this one. What are the signs going to be? 1 plus, 1 minus. And what are the numbers? What times what makes 32? We definitely want an 8 and a 4. And in this particular case, the way I have my signs laid out, I want to put the plus with the 4 and the minus with the 8. So what we're going to do before we wrap up is we're just going to write down our solution candidates, and they are x equals -4 and x equals +8. And then tomorrow I'll just give you a nice full day to work, okay? So let's pack up. The bell's going to ring in 30 seconds. But again, tomorrow, lots of time, so don't sweat it.
Oh, yeah,